This is Jack Jackson. In this video, we're going to continue looking at descriptive statistics, and I have several tasks and example problems that we're going to go through, and of the stuff that we've kind of talked about earlier in this playlist. And it's many times here I'm going to ask you to stop and pause the video and work out some stuff on your own, and then come back and check. So this video should give you a check to see if you are understanding and working out things correctly. Okay, so remember a couple things. We want to describe concisely, both graphically and numerically, some certain features of a data set. Okay, in particular in this video we're going to be talking about measures of size and relative standing. Remember, a sample taken from a larger group, and if we measure something on that, it's called a statistic. And a population is when you have everything, and we want to measure the everything, then that measurement's called a parameter. So S and S go together, sample, statistic, and P go together, population, parameter. Okay, so for our first task here, actually we're going to come back to this several times in this set of notes and videos. Let's say we have a school fundraiser, and a bunch of students are selling boxes of candy. And when we get through, this is how many each student sold. So you might want to jot these numbers down if you want to be able to go ahead and do this. So you could pause it right here and write these numbers down. Okay, and okay, if you've done that, then there's a couple that you can't see. So let me go down here. I didn't get them all in one. Let me see if I can get them all in one. Okay, I've adjusted this now where I think we can see all the data at once. Okay, so we see all the students here, and we see the number of boxes each student sold. So this is our basic data set. You might want to take a screenshot of this, or write a picture of this, or write the data down so we can refer back to it in a little bit, because I'm going to ask you to do several tasks with this particular data set. So anytime I talk about student data sales or candy sales, we're talking about this data set. Now the first thing I'd like you to do is make a dot plot of this. Some people call this a line plot. So make a dot plot of this data set, and then come back and check your work when we get done. So press pause now. Okay, now that you have this dot plot done, what should it look like? It should look like this. Okay, so question is, what information is present in this dot plot, and what information that we had in the table is now lost? Well, the dot plot, notice, has every single data value there, so we know exactly how many boxes each student sold. What we have lost, however, is which number of sales go with which students. So we don't know, for example, that this only selling 2 boxes down here is Ashley, for example. And we don't know which one sold which amount. But we do gain something from looking at this. By having it organized this way, we can see that lots of students were kind of in this, certainly in this 9 to 20 range. That's almost all of them, just a few that were unusually low or unusually high, and a whole bunch right in here in the middle, and we can see which one is the most there, most often number right there in the middle as well. Now what characteristics we'll be interested in knowing about a data set? Well, in general, we're interested in these things: size, extreme values, measures of central tendency, measures of relative standing, measures of variability, measures of shape, outliers, and changes over time in the data set, or perhaps comparing 2 data sets to each other. So the first thing we can do is how many are in the whole thing. That's the sample size if it's a sample, or the population size if it's a full population. We use lowercase n for the sample size and uppercase n if it's a population size. What's the total number of candy boxes sold here? So how can we do this? We can find the numbers from here, but we can also see them back in the original data set. So here's our data set. What's the total number of candy boxes sold? Well, all you're doing is just adding these up. So we might call this X1, 2, and X2, and X3, and X4, and X5, and we could add all those up. And how many of them are there, first of all? We could count them all, and I think I already have a count down here. 44 is the count of how many. Let's say this is a sample, so n is 44. And so we might use this notation here. The sum from I equals 1 to n of x sub I is x1 plus x2 plus x3 plus x4. In other words, it's just adding up each one of these. This is x1, this one is 15 is x2, 12 is x3, and we're just adding up all those numbers. And so a shorthand for adding them all up is this capital Greek letter sigma. Okay, and the Greek letter sigma is like a Roman letter S standing for sum. So this is the summation, or just summing them up, adding them up. Now, one of the things that we might first want to do is go to the extreme values. Well, if you've got a dot plot, it's very easy to see the extreme values. The minimum is what? 2, and the maximum is 30, and we can read that off very easily from there. Okay, so we had an overachiever, Debbie, who sold 30 boxes of candy, and we had kind of an underachiever, Ashley, who only sold 2 boxes of candy. The quartiles in the box plot, we've already computed the ends of our whiskers there. Our minimum and maximum would be 2 and 30. Now, how do we find the other parts of the box plot? Okay, well, we want to find the median first. Since n is 44, 44 plus 1 divided by 2 is 22.5. So the halfway point is between the 22nd and 23rd. Now, since I don't have the data actually written out in order, but I do have it in order in the dot plot. So I need halfway between the 22nd and 23rd data points. So let's count up from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So where are we between this 22nd and 23rd, was it? Okay, well, 22nd, 23rd, and 24th point, they're all 14. So that will be 14 for the median. Okay, so 22nd, they're both, so the halfway between the 22nd and 23rd. So again, counting from the bottom, 22, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's the 22nd one from the bottom. And that one's the 22nd one from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There's a 22nd from the top. There's a 22nd from the bottom. Halfway between 14 and 14 is 14. Okay, so 14 is the median. Okay. Next for the quartiles. How about the let's go back to dot plot. Sorry if I made you dizzy there. What is the lower quartile, Q1? Okay, well, there's 44 data points, so the lower half would be the lower 22. So we want to do half of that, which would be 11 and 11. So the halfway between the 11th and the 12th one. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the 12th one are both 12. So Q3 is 12, right halfway in between these two, right there. And then for the Q3, we want to go between the 11th and 12th from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11th and the 12th one are both 16, so 16 would be the one there. Or from the bottom, let's see what that would be. 44, okay, let's see, we got the top 22, so we're adding up from there. So anyway, it's between those two. So let's see. So what did we come up with? We came up with Q3 is 16. So here are these. Here it is right here. So here's a box and whiskers plot or box plot below this. Notice we have a whisker at 2, a maximum at 30. We're not taking into account outliers on this particular box plot. So this is not a box plot with outliers. And then we have 12 for the Q1. Q3 is 16. And the median, sometimes written X tilde like this, is 14. And let's line that up a little bit better. There we go. 14, that's lined up with that. And so we line them up with the points on the number line. And I've just illustrated it along with the dot plot. I'm using the same number line for both things. Okay? And so we can see that 1/4 of the data is down here, 1/4 is in here, 1/4 is in here, and 1/4 is here. So this is 1/4 of the data, and right here are these points. These dots, they're real close together, that's 1/4 of the data. And then 1/4 of the data is right in here, and 1/4 of the data is down here, or at least approximately. Let's stop the video there, and we'll do some more exercises in the next video.